Good afternoon, everyone. Welcome to Uwatha Distant Education and ENG4C. Yesterday, we discussed key question 26C novel analysis, questioning character. So, we did go into a little more detail than is asked here in the key question. That is on page 28. We also defined what are called static and dynamic characters on top of the flat and round that are mentioned in the actual key question. And that's fine. The key question does ask for specifically examples of round and flat characters, but um, you can also use the definitions and descriptions of static and dynamic to supplement your writing as well. Now, the best way to do that would be to watch the actual video of yesterday's class. All of that pertinent material is in there. If you have any questions at all, please contact me and we can discuss different types of characters in your novels. I've read all the novels, so I'm pretty familiar with the characters in each of the different novels, so I'm here to help. So, we also started in on the reading graphics activity 3, which starts on page 29. We went through the learning goals and success criteria. I'll review the success criteria there again. That can be found on page 29. You will know that you are successful when you can identify the purpose of different types of graphic text, including diagrams, tables, charts, and graphs. You will be successful when you can evaluate the effectiveness of two graphs based on criteria. You will be successful when you can share your evaluation of two graphics with your teacher, and of course those graphics will come from your research on the internet. And finally, the success criteria for the novel analysis, another novel analysis, which we won't be doing today, but that comes in tomorrow's class, okay? We'll touch on the key question itself just to introduce you to it, but the actual content will be ingrained or ingrained, will be given in tomorrow's class on realism in the novel. So we also looked at the introduction to the content section on the following page, page 30. What is graphics? The criteria for effective graphics. There's a bulleted list here. Important to use these criteria and identify them when you do go looking for examples of graphics that you can complete your key question with. But we'll talk more about that later. We also went through the different types of graphics very loosely. We just looked at the examples, and now today we'll actually include the explanations for each type of graphic. So we are on page 31 right now. And the first type of graphic that we are going to look at is tables. So in tables, the data, that's the information in the table, is organized into columns and rows. A writer might use this to condense a large amount of information into a smaller space. It also allows a writer to communicate different pieces of information that fall into the same categories, such as a course calendar for a college or university. And there's our example immediately to the right of it in the next column. Charts and flowcharts. They show the relationships between elements. Flowcharts indicate a sequence of steps. You might use a flowchart to explain a procedure to someone, such as how to close up a store at the end of a day. The one here is, it looks like a procedure on how to climb or crawl out of bed, right? So each of these different icons in the flowchart mean something different. So one of them might, well, we have the start and the end buttons, right? And then these rectangular orange ones they look to be somewhat like action buttons, and then there's this triangle, or no, it's not a triangle, it's, what's the right name for that? Hectagon? It's a four-sided, irregular type of geometrical symbol. And it seems to be some kind of decision process there. Get ready to get up? No or yes. And that's how these work. And so in Microsoft Office, we have all kinds of these different flowchart icons. Let's see. Right here in Insert menu, and then we'll click on that, and there you go. You can see, well, there's tons of icons, and these aren't the actual flowchart ones. Let's see if I can find them quickly for you here. Nope. Okay. All right. Shapes. I believe shapes. There we go. See that? Basic shapes. Each shape can represent a different type of actions. Could represent decisions, the beginning or end of a process. We have block arrows over here, signifying direction, of course. So we're not going to actually be building these, but if you come to a time when you need to, that's how or where you would find these icons. And then we have diagrams, of course, on the next page, on page 32. Diagrams are simple line drawings that represent an object. In our example here, we have plant cell structure. You might find line drawings in textbooks or in manuals for things like cars and appliances. The diagrams can be in 2D, two-dimensional, or 3D, three-dimensional. The adjacent diagram is an example of a 3D diagram. And then timelines. Timelines show an order of events. These are most often used to indicate important dates for a historical event or in the development of a product. And in our example here, it seems that, well, it's not just one product, but it's the development of technology starting with Windows XP in 2001 and finishing off with Office 2010 in 2010. Now, there's a number of Windows items here, but there's also Facebook launching in 2004. Blu-ray players were released in 2006. Twitter, 2007. So the different points here on this timeline are influential technology that has affected us in the time in these 10 years between 2001 and 2011. With pie charts, they're the next item here. These show divisions, relationships, and parts of a whole. A writer might use a pie chart to show how much of a person's income is devoted to costs like housing and food as compared to entertainment and clothing. Continuing on page 33, we have bar graphs. Bar graphs compare different amounts, quantities, or levels. In the adjacent example, the writer is using a bar graph to compare income for a business in 3 different years. Here we have 2003, 2004, and 2005. Each color so there the bar graph here for 2003, there's 3 different colors, right? Looks like a light indica type of blue, a mauve violet, purple, and then green, right? Each of those colors represents a different element. We go over to the menu here, right? The light blue represents total expenses. The mauve purple, total expenses. And then the green is the profit loss. If you wanted to show change over time as opposed to differences in a few years, you would use the next graph, which we'll look at in a second. One thing I want to mention about this graph right here is on the y-axis. This is called the y-axis, the scale going from the bottom to the top, and then the x-axis would be from left to right. But in this case, we have the numbers, the values of, starting at 0 and then in 10,000 increments up to 90,000, as you can see there. So what's the next graph do then? Line graphs show change over time. A writer would use this when he or she wants to really make change over time visible. A writer can affect the reader's perception of the information by using a different scale on the x or y axis of the graph. This is true for the bar graph as well. If my scale started at minus 28 degrees Celsius, you wouldn't see such a dramatic difference between the highs and lows. Think about this when you read or create graphics. Okay, so here, though, we start at 0, but then there's a big jump to 18. Right, there's data missing in here, in this axis, and it's Celsius degrees. but none of these points fall below 18 degrees, for instance. So we're just looking at part of the equation, part of the picture from 18 to 28 degrees. And we've skipped out or edited out 0 to 18. So that's okay as long as we indicate that we are doing that. And then in this axis right here from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, the days of the week, we include the whole week in here, right? Okay, so next section here is on page 34, strategies for reading graphic text. When reading text, we generally read from the left to the right and from the top to the bottom. We don't necessarily read graphic texts in this way. So first of all, you have to orient yourself to the graphic. Where is the title? Okay, we're looking at this one right here. There's the title right here, Autumn National Temperature Departures and Long-Term Trend, 1948 up to, well, the chart can keep changing. See, it's up to 2015 there now. If we went searching on the internet, we'd probably find it has gone past that, the data or information that they have. Okay, so this is something that will change over time. So the title is really important. It tells us what kind of information is in this graphic. Number 2, have any sources been provided for the information? Is the data recent? Is the data reliable? So there is a source right there. We have a link to Environment Canada 2012. So we know right away that, well, geez, it's 2026 now. There's data missing, and the reason is that, this course was, or the information from this course was compiled a while back. But that's fine. We don't need to update this. It's just an example. It's just something to illustrate. Number 3, examine any headings or labels so that you know what information you can expect to find in the graph. Okay, let's look at the anything here that might indicate what we're looking at here. Okay, so it's from Environment Canada, right? Then on the left, this axis right here, we have that Celsius sign, right? So we know that this means Celsius degrees. So we have the 0 right here in the halfway point, 0, 1, 2, 3, 4, and then minus 1, 2, and minus 3, and minus 4. So these aren't the actual temperatures. These are the temperature departures from long-term trend. So that means, basically, that these are the so for every year, these are changes in the average temperature, up and down, right? From 0 to minus or positive. Right, so let's just quickly look at an example here. Let's look at 1950. And so, of course, the axis is the years. From 1945 to what we have here, 2015. But let's look at 1950. So in 1950, there was the autumn temperatures were cooler by 1 degree in that year. And then in 19, looks like about 54, right? Because you can see these hash points here, hash marks, between 50 and 55. So we would interpret this to be roughly, well, I'd say maybe 1953, there was actually a rise in the average autumn temperatures, right, of just over 1 degree. So you can see how it's gone up and down and fluctuated over the years, but there's a general trend, right, that's indicated by this orange line here, that the temperature, the um, depart, depart, departures from the averages and the long-term trend is rising. So that's what this short snippet in time tells us, the information that we have on it. So follow the flow of the graphic, paying attention to any arrows or labels that may be present. Number 5, sometimes graphic texts stand on their own, but they are often used to clarify written text. In this case, to connect the graphic to the text, you would have to go and visit the site in that example. So, creating an effective graphic text. Audience and purpose. Consider how much your audience already knows about the subject. The amount of knowledge they have will determine the language you use. The way you label your graphic and the amount of detail you can use in your graphic. Think about what you want the reader to be able to do with the graphic you present. This will determine the type of graphic text that you use. Do you want readers to compare information? Then you might want a bar graph or a table. Do you want to show process? Then you might use a flowchart. On page 35, type of graphic, choosing a graphic. The type of graphic you choose will depend on the type of information you want to convey. If you are writing a procedure, you may want to use a flowchart to indicate a sequence of steps. If you are trying to show the difference in data plans from different wireless providers, you may want to use a bar chart. Okay, so we have the key question, which we'll go over here now for this part of the activity. And then I have a website that I will take you to that will run through good and bad graphics. This should help you out quite a bit in setting up your criteria when you go searching for your own graphics on the internet. So, this is what you will need to do for key question 27. Once again, please keep this assignment in your portfolio folder. You will refer to it in your culminating task under writing. Do some searching online and find an example of graphic you think is effective based on the criteria established in this activity. And that was already listed. We looked at that previously, but I have more information here I will share with you very shortly. Then find one example of a graphic you think is not effective based on the criteria in this lesson. It's probably easiest to find your examples by doing a Google image search. Your search query could be line graph, for example, and then just make sure you are using the image search feature. Provide an explanation that explains what makes the one graphic effective and the other graphic less effective. Be sure to use specific criteria from this activity to support your selections. Okay, so just reviewing here, scooping back up to, or scrolling back up to where these criteria for effective graphics are on page 30. Right here, visual appeal, labels, titles, proximity to the text, and compactness. This is a good place to start. Now, you might want to write some notes in the open spaces here following our, or as we go through this website, okay? All right, this is put out by palmersearch.com. It's a blog of good and bad examples of visual or data visualization. So in the big sense, that's what they call this data visualization, looking at text and visualizing in your head what they actually mean. So here we have some 10 good and bad examples. So I'm just going to scroll down to the actual examples here. Here's example number 1, presenting qualitative data. So we have quantitative data, which is numbers and amounts and things like that, and qualitative is like qualities of different things. Like let's say a house is red or green. That's qualitative data. So in our example here, and this is a spreadsheet, right? You can tell how it's set up here. We have these columns. They're listed as A, B, C, D, E, F, G, and then the rows 1, 2, well, we have down to 33 here. And then we have in this first column all these ages. There's quite a bit of information there, and it's hard to focus, right? First name, last name, gender, their email addresses, the work phone, and mobile phone. So spreadsheets are really great for certain types of information. For making calculations, actually, that's what I find them very useful for. But information like this is best contained, put into what we call databases, right? It's easier to see and find information. So it's pretty hard for us to visualize this type of information. So it contains all this qualitative information about these different people, but it's pretty hard to visualize and sort out. But there's 2 ways to visualize it. One is called the card view and the gallery view that follow. Okay, so have a look at this picture here. And this is more from what we would see in a database, right? So we would see these cards or tables, and are broken down into actually the last names of the individuals that are in this original spreadsheet file here. So we just can look at one at a time, and we can get all that important information just by looking at one card or one table. Um, Much easier to read like that and visualize who this person is and what are his qualitative, that is, the important information related to that person. Here's another bad data visualization. Example number 2, a pie chart with too many categories. So pie charts are best used when there are 2 or 3 items that make up the whole. Any more than that, and it's difficult for the human eye to distinguish between the parts of the circle. And this one is quite large, right? But um, generally, if we have a document, we don't want to take up that much room, so this would be maybe a quarter the size, and it might be hard to pick out Japan and Russia and India in here. So instead of this chart, we would want to replace it with something like this below, which is a proper bar chart. And we can see how easy it is to compare the CO2 emissions of these different countries now. Now here, we can't, we aren't able to get like percentages, and Japan looks close to Russia, and EEA looks close to the United States. But there is a variance there between them, and we can see that much easier with a proper bar chart. Right? We can see EEA. Well, that's actually the European Economic Association, I think. And their percentage of CO2 emissions is, wow, it's almost 5% less than the United States. And then, let's see, Russia and Japan, there's quite a bit of a difference when you actually look at the height of the bars and the percentages that accompany them, right? Russia 4.90%, Japan 3.50%. Following that is bad data visualization, example number 3. Multicolored bar charts. Okay, so that's the same chart as above, right? But we've made all of the different bars different colors. So it's important to remember that it might look pretty, but the more colors you use, the less comprehensible the visualization will be. With more colors, it means more categories that the brain must process. right? So you can look when you compare. It's the example, the bar chart above, and this one with the colors. That the bar chart above with just the red works just fine. So we want to make things clear and easy for people to read. So another example of better data visualization is following that. Now we have China, which is the leading polluter with 29.40%, right? And so we mark that as red, color that in red. And then the rest of the countries, we just make gray. So that highlights, pinpoints the country that's most responsible for CO2 emissions in the world. Gets the point across of who are or who is the greatest polluter. Okay, now, sorry. We can also this is an example of a very simple pie chart. Female 9%, male 91%. So this data visualization helps us put things into perspective. When we look at this, we think, wow, yeah, it's very dominant, the male portion of this circle. Very, very dominant, right? Here's another example of bad data visualization, horizontal bar charts. Horizontal bar charts suffer from the same issue as pie charts. Once there are too many categories, you run out of space to include text and it becomes hard to digest. Yeah, take a look at that. Right, there's look at the x-axis down there. 360 experience, RPG, exploration, action, simulation, and it goes on and on and on. It's really kind of hard to focus in on one of those topics. And then looking at the chart, it's hard to really figure out where it's going, each of the different lines. Too congested. But it's easier to look at this type of data or information using vertical bar charts, like our example here. Much easier to read, easier on the eyes, right? We can easily follow from left to right these different topic areas instead of having to go at a 45-degree angle and turning our head to look at them. Right here, we just keep straight and look from top to bottom. Much easier for the brain to digest. Here's another bad data visualization here. Example number 5, too much information. It's a nice pretty chart, right? We have all these states in here, but there's overlapping happening. Property crime per 100,000. Bubble radius is proportion to the individuals below poverty line. So each circle there, its radius is proportional when we compare it to the other each state, one state to another state. Like Michigan looks like it has the same number of individuals as California. But over here, it's really hard to make out the different states and the actual circles that represent them. So that information is really hard to digest. Instead, you may have to rearrange your data and create multiple graphs to convey your point. Here's another example of data visualization, 3D graphs. Okay, so we have all these 3D graphs here, but once again, too much information. It's all very confusing visually, trying to isolate each of these different parts. Here's an important one next. Charts that don't start at zero are misleading. Now, we did see an example in our unit of that, which it's not too bad how it was placed in there. But sometimes it makes it much more difficult for us to understand what we're looking at. So let's take a look at this one. This is number of sales for each product. Now look at this. We have product number 1, and it goes up to 95. So 95 of these were sold. And in the second example of product number 2, we have probably around 76 of these items were sold. Now notice that the number of sales starts at 70 right here. So when we look at these two, it looks like, wow, it looks like we are selling 5 times as much of product number 1 as we are of product number 2. But that's not the case. Like if we filled in from 0 to 70 for both of these products, then we would see probably a drop of 18, let's see, from 95 to 77. Yeah, so that's about 18 items, 18 products difference. And so that would indicate that there's not that huge of a difference as what it looks like from the actual graph. There's our right example right there, eh? From 0 up to 100. See? Notice how much closer they are? And then this example, here's a time series, right? From March the 8th to May 31st. Okay, so we have these values over here on the left, starting at 54,500. And then going up to 62,500. So there's a lot of information missing. Since the y-axis doesn't start at zero, it's easy to fool someone that the price of something is exponentially rising, where in actuality the increase is only about 10 to 20%. Okay, so there's the increase from 54,000 to, oh, let's say it's about 61,000, let's say. So that's about $6,000. But it looks like when we look at the picture here, it looks like it's jumped, 6 or 7 times the amount. Um, Next, tables with no context. Spreadsheets and pivot tables, simply a type of spreadsheet um, with no context. They're meaningless in this way. This one is a pivot table showing which product line and gender are generating the most income. Even though it's ordered from highest to lowest, what exactly do the numbers mean? How high is $1,580? Okay, so hard to discern what this table is actually telling us. There's a bunch of information here, but what are we comparing it to? Sum of total cost for each product number and order category. So, product number and order category, we obviously have too many criteria, categories in here to be of any use to us. So the next one is a good example of a table with context. Instead of just giving a raw number, it's highly recommended to provide a mean deviation. That is how far a number is from the average. Right here we have the averages. Average of 83. Okay. Right. So female number one here, she's at 90. Male number one is at 88. So both above the average. Now here's another example of too much graphics and no structure. Wow, eh? Quite the picture here. Trying to figure out and what type of information we are looking at. All of these little icons here, they add to the confusion. We have Netflix, Grubhub, Instagram. These are all different. Uber, service organizations, I guess that's what you would call them. And each one has a little icon here. Really hard to compare them for one thing. Just a bunch of data. You could probably do um, as good a job by putting everything in a list. All right, so one more example of bad data. Whoa, we're running out of time. Uncalibrated y-axis. Okay, we don't know what these interest rates are telling us. Okay, so there are some bad examples, and you can look for bad examples on the internet doing Google searches. You just simply do bad examples of graphics, and you can add that to our key question. Right, so hopefully that helped you out a bit, looking at actual examples, and you can complete that and find a good example of good graphic and a bad graphic on the internet. If you need any help with that, please contact me. Otherwise, we're going to move on tomorrow and take a look at our novel analysis on realism. Thank you very much for listening in on us today. I hope you enjoyed the class.